Hi there, Jeff here. Welcome to my channel. In this video, I'm going to discuss about AWS VPC Basic Network. So as what you see on the diagram, we have VPC, Internet Gateway, public subnet with 10.0.1.0/24 network and the private subnet 10.0.2.0/24 within the VPC 10.0.0.0/16. I'll be discussing route table, internet gateway, network ACL, security group, and instance. Those are AWS VPC basic network, and also I added the NAT gateway for the private instance or subnet to communicate from the to the external or to the internet. To begin with, we have to sign in to the AWS console. Then I have to sign in, and then I have MFA code for additional security. So here we have various AWS services. We have EC2, IAM, blockchain, S3, DynamoDB. Especially those are free for free tier account. So to begin with the basic network, we choose the VPC. VPC it's like you have a virtualized network in AWS. You have your own data center or subnet. Initially, you don't have a VPC network, and then you have to create your own VPC, which is based on our diagram. It's 10.0.0.0/16. Hold on. We can name it demo VPC. Tenancy, you can leave it as default, then create. Here it is. VPC is now created. And within VPC, you have public subnet and a private subnet. Then you can create your own subnet. We can name it demo public pub subnet pub sub, which is included in the which is within the demo VPC. You can choose AZ1A, which is Hong Kong, and our public subnet is 10.0.1.0/24. Then create. That's it. You now have a public subnet. Then you create another one, demo private subnet, which is also within the demo VPC. We can choose for now same availability zone, which has 10.0.2.0/24. Then create. We now have private subnet and public subnet, which is based on our diagram. for for the instance or the network to have internet, or for it to communicate from the outside, you have to set internet gateway. Demo IGW or internet gateway. Okay, and you have it as what you see, state is detached, meaning it is not attached to any VPC. So you have to attach it to the VPC by right clicking, or from the actions attached to VPC. Then you choose which VPC you have, but in this case we only have demo VPC, or by using CLI you can type this commands, then attach. See, the state changed from detached to attached, meaning it's being attached to our demo VPC. But of course, it should have a route table. A route table controls it's like a rule, a route that controls the traffic in and out. Once we created VPC, we have a default route table. So we have to, for now, we can use this route table as for our public route table, or you can create another one for you. And then we can create another one which is for private route table. Attach to demo VPC, create. Okay. Then we can create a public instance and a private instance. To create instance, you have to type EC2, which is our virtual server in the cloud. Then instance. We don't have any instance yet, so we create one. You can choose free tier only. So, and you can also see free tier eligible. For now, we can use this one, Amazon Linux 2 AMI HVM. Then select, and you can choose instance type. You only have one instance type with a free tier eligible. You can use it. Then next, configure instance. What number of instances? We can use one, and our VPC, demo VPC, and this is for our public network. So this is a public instance. We use public subnet. Then we can enable the public, since this is public instance. You have an option to change it by going to the subnet. You can change it modify auto assign IP setting. Let's try it and then enable. Let's see what will happen. Then save. Then we go to the instance that we are creating. By default, it is disabled. We refresh demo public subnet and then hold on. Here it is. Use subnet setting enable. So it is enabled by default now. Add storage, next, add tags. We can have a name public instance. Next, you can create new security group or select an existing security group. We don't have existing security group yet. We can create new security group, um, public instance security group. This is security group for public instance. Basically, a security group is like a firewall in the instance. It controls the traffic going to the instance in and out. It's stateful filtering. Unlike we have also network ACL, which controls traffic in and out in a subnet level. Okay, we can so we allow all traffic to remotely access our instance, which is wrong. We have to specifically assign IP addresses that can only remotely access the instance. So in my case, my network review and launch. Create new key pair. You can use demo key pair, demo key pair, then download key pair. Save. Launch instances. We can also create one for our private network. So this is our private subnet instance. One demo VPC, private subnet, disable, add storage. Next, add tag, name, private instance, security group. You can select the existing security group. Public. We can rename the security group to instance security group. Launch. demo KP. Now we have private instance and public instance. Basically, our network is not yet fully configured, but let's try for you to understand if we can access it. So here, this is our demo PEM or key pair. In SSH or doing the remote from the Windows 10, you do SSH this the name of the key pair or the file name, and then EC2 user at, and then the public IP. In this case, so meaning we don't have access yet. Or subnet route tables for it to have communication to the outside. You have to change the public route table. So edit routes, add routes. So our target is our internet gateway. It's like our next hop to reach our internet. This is the demo IGW, the one we created. Then save routes. Subnet associations. Edit. For route table, we choose the public subnet. Save. Okay. Our security group, you can rename it to instance security group since it is being used for our private and public. Mhm. Let's change it later. Then we can try. Yes. So it said permission for demo kp.pem are too open. It is required that your private key files are not accessible by others. This private key will be ignored. Load key. So meaning this is permission error. So we have to change the permission. Go to properties. Security. Advanced. Here the owner is 1001. It's my user. So we have to only allow S15211001 to access this file because this is the key pair to access the instance. So remove. You can't remove system because this object is inheriting permission from its parents. Okay, so we have to disable inheritance. Remove system, remove administrator, remove. Okay, we're done. Apply. Okay. Then going back to our SSH, boom. We are now in the Amazon Linux 2 AMI CLI. When we do who am I, it's easy to user, right? So we will create web server. We will enable HTTP service here. Yum update HTTPD. So meaning it has internet access. Let's try to ping google.com, right? Yum install HTTPD. Yes. So we have now HTTPD service installed in this instance. Then we can enable or start HTTPD service. Enable HTTPD and then start. Enable means when you reboot, still HTTPD is running. Then we start the HTTPD service. Then we'll try to have a web page, simple web page. Welcome. This is public instance. Okay. Then it should be located here. var www-html index.html. Okay, let's see if that is the content. Okay, so we will try to HTTP on our public instance using this public IP. Copy HTTP only. So it's spinning, meaning it can't reach the server, the web server via port 80. So in this case, we have to change the security group, allowing port 80. When we check public instance, then security group, view inbound rules, we only allow port 22, right? We have to edit inbound rules. Add rule, HTTP, let's say all network allow web access from the outside. Okay, save rules. Let's try it again. Boom. Welcome. This is public instance. All right. So we now have a web server that can be reached from the outside, right? As you will notice, we don't have the public DNS IPv4. So how can we have a public DNS? So let's have a quick overview on the DNS resolution in VPC. We have setting enable DNS support and enable DNS hostname. Enable DNS support means it's a DNS resolution setting. It's by default true, and it queries the DNS AWS DNS server for resolution. And for DNS hostname, enable DNS hostname is for the DNS resolution setting, and by default it's false. Okay, it's for the public instance for the DNS resolution. So let's have a quick overview. So in your public instance, as you will see, your public DNS is set to nothing, right? So to have public DNS, let's have a DNS resolution first for enable DNS support. By default, it's enabled. And for DNS hostname, by default, it's false or disabled. So let's try to enable it. Then let's refresh the public instance. And now it has a public DNS of EC2, blah blah blah, Amazon AWS.com. So let's try to access this DNS. Boom! We can access the server via the DNS, right? So now we have a public instance accessible in the internet. Then we will try to SSH from the public instance to the private instance that we have. And then let's have the private instance access the internet as well. So first, let's move on to the difference between security group and the network ACL. So security group, as what I have mentioned earlier, it evaluates the traffic in and out from into the instance, right? But for the network ACL, it's subnet in the subnet level. It evaluates traffic in and out. So security group is stateful filtering. Network ACL, it's stateless. You have to indicate the inbound and outbound traffic. So by default, we have network ACL. Let's check the network ACL. We have network ACL by default, which is associated to our two subnets, right? Then we have inbound rules allowing all traffic from any source to our instance, right? And then outbound rules from our instance or from our subnet. It allows all traffic. We can rename it VPC ACL demo. We can use it for now, but you can specifically configure the inbound and outbound rules. But for the sake of our video, we can use the all traffic. Okay. Then from the public instance, we are going to SSH. Oh, why we don't have access? Okay. When we do SSH to our private instance, okay, it has no, but it has a key pair as well. We have the demo kp pem file, so we have to download the key pair here. By doing so, we can then we can download by demo kp.pem shift I shift insert, sorry, copy and paste, then so we now have demo kp, but of course we have to change the permission, right? So change 0400, we can try it, demo kp.pem. All right, then we do ssh dash I demo kp like what we did on our public instance, EC2 user 10.0.2.113. This is the private instance IP. Okay, it's not I couldn't SSH it. We can check the security group. Security group, because on our security group we only allow SSH from my network to the instance, but we should also allow our VPC network to access the private instance. All right. So inbound rules SSH to our remote access from our network. Edit inbound rules. Add rule SSH. Okay. From our VPC 0/16. Save rules. Okay. Since this is stateful filtering, we are fine. Outbound rule. All traffic are allowed. We cannot try. All right. All right. We are now on our private instance 10.0.2.113. So who am I? When we do google.com, it has no internet, right? So to have internet, we have NAT instance and the NAT gateway. But in this video, I'm going to discuss the NAT gateway. NAT instance is it needs more configurations. Unlike NAT gateway, it's simply just click and simple steps to configure. So to configure NAT gateway, go to the NAT gateways, create NAT gateway. NAT, our NAT gateway should be on our public network, right? Public subnet. So elastic IP allocation, we don't have yet. So allocate elastic IP address, or we can click the elastic IP on our dashboard. But for now, you can click allocate elastic IP address here, then create NAT gateway. So for the NAT gateway, you have to edit, configure the route from our private route table. As you remember, we have the public route table and the private route table. Our public route table is pointing to our internet gateway, right? And for the private route table, we should configure the default route to pointing to our NAT gateway for it to have internet or access to the external or internet. Okay, so it may take 10 to 15 minutes to change status. But for now, while we are waiting, we can change the route tables. So as you will see, our public route table is configured with the internet gateway, right? And our private route table should be configured with this one. NAT gateway. That's our next hop. Or if you have NAT instance, it's a network interface. Okay, NAT gateway, and we have this NAT gateway we configured, which is still in pending. And let's see if it changed. Save routes. Okay. Of course, we have to associate our private subnet. So our private subnet is this 10.0.20/24. Okay, save. Then we go to the NAT gateways. Now it changed to available from pending. Now let's try to do ping google.com. Right? It pings but then stop. Alright, it's just loading. Okay, ping google.com. Call google.com. Okay, and now we have our public instance and private instance communicating to our internet. And this is for now. Thank you for watching and listening. Hope you learned something about AWS basic network technology and its feature. All right, thanks. Have a great day.